And welcoming our last speaker of the session, Gaurav Venkataraman from Trisk Bio.
I'm Gaurav. I'm the co-founder and CEO of Trisk. We are an AAV manufacturing organization, and what I want to talk to you about over the next couple minutes is how we think about really giving our customers, that's developers, both capsid developers and therapeutic developers, more agency, and the role that scalable manufacturing methods play in delivering that. So I want to start by kind of asking the question, how should AAV manufacturing work in 2026? What's possible? What does it mean to give developers agency? And from our point of view, you should really offer three things. First, a very quick construct assessment. After that construct assessment, it should be possible in 2 weeks, kind of including analytics, to get a first batch made at reasonable VG scale, so mid E13 to low E14. And then crucially, after that first batch is made, you should really have de-risked large batch manufacturing. So this first batch should enable large batches to happen effectively on tap. Manufacturing this construct should no longer be a majorly risky part of your Gantt chart after the first batch. From our point of view, that future is only possible if scalable manufacturing methods are used from the beginning. And by scaled manufacturing methods, I really mean suspension upstream followed by chromatographic downstream, in contrast to adherent and centrifugation-based purification methods. And the reason is because scalable methods are really superior on most of the dimensions that matter. You generally get better quality. Chromatography is very good at purifying out host cell proteins, host cell DNA. Infectivity tends to be better. The operational complexity of running these things is lower. Because the operational complexity is lower, you can run processes faster. Because you can run processes faster, you can generally reduce the cost. The per VG cost of running scale methods is lower than running non-scaled methods. The problem is that scalable methods tend to involve bespoke development work up front, whereas with non-scalable methods, you can generally get something out without having to do much development work. And so what we've been working on a lot at Trisk is how to pull these advantages of scalable methods forward by dealing with this development work problem. Okay, so I have a solution for you, but it's not a magic bullet. There is development work, it has to happen somewhere. And so you can imagine kind of two extremes. The current paradigm is kind of this platform process where some development work happens up front. When a particular construct comes in, a new kind of development project starts with the platform process as a jumping off point. And if you're a bit of glutton for punishment, you can imagine the other side is to pre-run as many capsid and transgene combinations as possible, so you have a lot of processes ready to go, so you can handle the variety of things that might come inbound. And what we set the company up to do is be as far on this dimension as we think is feasible. So what I'm talking about is front-loading development by generating really a book of processes for each capsid that we onboard. So how we work is upfront, we do capsid onboarding. We generate really a book of varied processes depending on how the capsid is behaving. That allows us to have a more streamlined project flow where transgenes come in, we can do a quick assessment. We can then select a process based on how the transgene is performing, and then we move to parallelized manufacturing at a specific spatial scale in order to provide forecastability. So what goes into a book of processes, what I'm talking about, it's understanding the upstream and downstream space. And so here's some representative data. Upstream, we want to understand as we traverse various directions in parameter space, what are kind of the yield quality trade-offs. And we also want to understand kind of the bounds of upstream quality. And so here's an example of kind of low quality. We like to generate sub 10% fulls because we need to be prepared for that. And also we like to push the full out of harvest as far as we can. The best we've been able to do is kind of 60% full coming out of upstream harvest. Downstream, we generally like to have enough control over chromatography, particularly IEX, to purify out partials. So this is a novel capsid. We generate partials on purpose and then doing partial purification, going from pure empties through various partial species to extremely full. The benefit of doing process books, these collections of processes, is that you can really do scalable manufacturing, even for novel capsids, quickly under genuine commercial constraints. So today I'm happy to announce, this was an example of a contract that came in. We got it to kind of 25% full upstream, and then through downstream, we were able to ship this at above 90% full. And I'm happy to announce today, this was a capsid that we shipped to Dyno. And this was done under real commercial constraints. There were a certain number of weeks we had for the project. There was a budget. Material needed to go out the door. This wasn't like an unlimited research batch. This was enabled by the upfront development work that had happened. We won't always be able to package at this level, and nor should we be able to, given the variety of transgenes that will come in. And so another representative example here is a different construct, different transgene, 7% full upstream, getting it to 71% full to ship out the door, again, subject to like genuine commercial constraints to get these things into NHP so people can test them. So we're doing all this upfront work because we really want to help AAV developers win. We work with capsid developers by onboarding capsids, developing these books of processes, and then that makes it easy for therapy developers to come in. You can benchmark your transgenes against things you have experience with, and hopefully offer you very aggressive pricing and timelines. So I'm Gaurav, as I mentioned. Tom, our CSO, is right there. We're based outside of London in Stevenage, England, but we have customers kind of on multiple continents, and our investors are US-based, so we've raised 2 rounds of funding, most recently from Antonio Rodriguez here in Boston, Matrix Partners, and the first round was from Max and Sam Ullman. And so really excited to bring scaled methods and much faster manufacturing to the field. Please come talk to us about it.